All right, so now we're going to have some comments from our current Vice Provost for Research, who was also for 6 years the director of IBB. And so where would you like to stand?
I'll stand right
Right there? Okay, good.
On the podium is where you want me to be, right?
Slides.
Yes, exactly.
Okay, thank you.
Thank you, Jane. Thank you, David, very much. So I have a kind of unique perspective as the former director of IBB and as a faculty member, and now as vice provost. I've seen IBB's power and effectiveness in helping bridge the gap between different disciplines and all of that in terms of life sciences, biosciences, bioengineering, the Texas Medical Center. But this is an event, we have a little bit of historical perspective required here. This is the 30th anniversary of IBB. So I'm going to take you back in time a little bit, 1986. Okay, now for some of you, 1986, if you were to see a picture of me or perhaps of Rebecca, these would be embarrassing pictures, right? We were listening to, new wave music. Probably she had shoulder pads. I had a collar that probably went something like this, right? It was a very interesting time period. But at Rice, big things were already happening. Smalley had discovered the buckyball, for instance. Materials were already ascendant at Rice as one of the things that we did incredibly well. And IBB was founded by Fred Rudolph and Larry McIntyre to sort of envision how Rice Life Sciences might work in a new and interesting way that other universities weren't doing. So the idea of combining classic biology, ecology, evolution, engineering together in this way in 1986 was a pretty radical concept. Very few schools were thinking in these kinds of terms around engineering and sciences being merged in the life sciences in this unique way. And in part it had to do with the fact that the Texas Medical Center is right across the street. There was a lot of opportunity to do basic research and translational research in this kind of new way of thinking. So you take it for granted, now those of you who are students, take it for granted now that engineering and science and medicine would be integrated in this way. But in 1986, that was a really new idea. And there were very few schools, I would say nearly none, that were actually thinking in this way. So when IBB came about, right, the buckyballs had been discovered. And Rice was thinking of itself as an important school for the new materials that would change medicine and change life sciences in general. So when we think about coming together in this way, that was one of the founding principles of IBB. And since that time, we've progressed in our understanding of materials, right? So on the left side here, we have the original 1986 discovery of buckyballs, and then we rolled them into nanotubes, and then we've got gold nanoparticles, which are very important for diagnostics now in a lot of applications in medicine. And now you see Jim Torres here. He could tell you a lot about graphene. We've got lots of people studying these fundamental materials. And what I want to sort of link for you is the idea that the materials on the left, right, were also followed by some material innovations on the right here in the life sciences. And so over here on the right, we start with the creation of IBB and biomaterials, and I would say advanced biomanufacturing, or the idea of building materials like this in biological molecules was kind of a pipe dream, right? There really were no materials or complex materials in use in 1986 for this application. Now, if you look at the same progression of time over on the right, you can sort of see that those of us in the life science, I'm a biochemist by training, so we've kind of lagged our chemistry buddies, our physical chemist friends over here on the left a little bit, but we're catching up rapidly, right? So what you see over here on the right, you see tissue engineering really happening. That was one of the very early areas that where the young bioengineering department set its stakes in the ground and had great success. More recently, we have innovations in quantitative and synthetic biology, which are, I think, again, the future of life sciences. And what I imagine happening is a convergence of these two channels, basically, where the materials that are being made over on the left and the materials and the approaches on the right are going to be integrated into a larger, more holistic understanding of how to apply those materials into neuroengineering, how to hopefully to regenerate the things in my body that are now wearing out with age, right? So there's a lot of applications of these fields that are new, and IBB is going to kind of be at the center of this integration, right? So Jane's challenge, right, is to integrate these programmatically. And that's an important mission for IBB going forward. So I think one of the challenges to the students and to the faculty that are here is to help Jane do this, right? Because she can't do it alone, right? Our office will help, Paul will help, we will all help. But in the end, the ideas have to come from faculty and students and how we're going to build this relationship together and with the Texas Medical Center. So IBB has come a long ways. One of the other things that I don't think most folks really appreciate is the historically important role of IBB in developing the campus itself. So probably most of you don't know that IBB was responsible for the development efforts to build the George R. Brown building on campus, as well as the renovation of Keck Hall, two of our most important buildings on that part of campus for doing research, right? I'm in Keck Hall, it's where my lab is. It's a fantastic building. It's where in the early days, bioengineering was in GRB and in Keck Hall as well. One of the other important things that IBB accomplished, and this is again historically really odd to think about, was at the time there was this, in this early period of IBB, there was this new department. Not too sure how it was going to do. It was kind of a newly configured idea in faculty called bioengineering. All right? So that department starts off as an idea by essentially Larry McIntyre with the support of Fred Rudolph, who was the chair of biochemistry and cell biology. And one of the important missions for IBB was to support the growth and development of that young department, which has now grown into one of the best departments in the country and in the world. So I would say if IBB did nothing else but that would be an amazing accomplishment. But it's accomplished significantly more than that. So, they've developed not only bioengineering, but we've got funding from the Hamill Foundation, which has been, in the case of the Hamill Foundation, went from around $650,000 in funding that we received over time to over $18 million in sponsored research projects, a huge return on investment for the foundation, for instance. And seed grants, as those of us who are faculty know, are really critical to developing your new ideas, because you can't go to the federal government anymore with a good idea and have much chance of getting it funded. You actually need foundations and seed grants to get things going so that you can actually build the collaborations, build the preliminary data you need to be successful. So IBB is a critical player in helping us develop those new ideas too. And again, that's something that Jane and Paul are going to, I think, really make part of their new emphasis in the coming years. And of course, I think a lot of you already participate in all the outreach that IBB does. And so one of the things that I'm particularly proud of when I was director of IBB is we expanded our outreach component to engage the city of Houston with Chavez High School, for instance, to the Science Academy of South Texas, which was a program that Jennifer West started. So IBB remains an important player in integrating STEM education into our community in a very Rice-specific way that I think allows us to bring faculty and high school students together to keep them in science and engineering, which is an important mission for IBB as well. I think one of the most recent achievements for IBB that I'm particularly excited about is, and it goes back to this earlier idea of integrating science and engineering so tightly, is our new PhD program in Systems, Synthetic, and Physical Biology, SSPB. So that's a new interdisciplinary PhD program that actually goes across departments. So it's not sitting in a single department, it actually is housed in IBB. So the students that come into that program have faculty to choose from that are from any of the departments: chemical and biomolecular engineering, biosciences, bioengineering, chemistry. They can go to any number of these other faculty spread across different departments. And so SSPB represents this new idea of what I'd call quantitative synthetic biology. So as biology becomes less observational and more predictive, if you understand the rules, this is what my engineering friends tell me, if I actually understand the rules of something, I should be able to program and design, right? I should have outcomes I can predict. And now biology is getting to that point where we can program cells, program materials to have outcomes that we can use and understand in medicine and in basic discovery. So this SSPB program is really founded around this idea that we can do this now, and we're training a new cadre of students who are sort of new scientists and engineers that can think across those traditional boundaries in a big way. So at this point, I just want to thank all of you for attending. I'm going to throw it back to Paul and Jane at this point to get on with the ceremony, but I want to thank you for being here and thank you for your support of IBB over the last 3 decades. Those of you that have been involved with IBB know how important it is, and I think with Jane in our new leadership position, I have incredibly high expectations for her. So no pressure, though. No pressure. This will be fine. But I think anything you can do to help her be successful would be fantastic, and I think she would deeply appreciate. So thank you very much.